right, so again, today we're just working on substitution, which we're dealing with systems of equations. And to remind everyone, a system of equations is literally just two equations or more put together, but we're just dealing with two, right? So the ones we looked at yesterday were these two, just two equations that you put together, and you have to solve for both x and y or a point. And our first way to solve them was by graphing two lines, and then their intersection was the answer. And then yesterday we looked at substitution, and today we are also going to keep working with some substitution to hopefully solidify some of the ideas that we have. Okay, so again, these steps are here. I'm going to put these steps here, and I'm going to scroll through them so that on the video, if you need to go back and look, you are more than welcome to go back and write down these steps. But I think that it just makes, I think it's easier that instead of memorizing steps or looking at steps, not only is it easier than memorizing steps, or I should say it makes it easier on you than memorizing steps, but top of that, it also helps you understand what's happening. And so I think when you just know what's happening underneath, that's better than memorizing some steps. So I'm not going to spend too much time on them. Now again, substitution, think of what the word substitution means. If you substitute a player in for another, you swap a player out, and that's exactly what we're doing with these. If we have a variable that's already solved for, we were used to having y solved for, but now we have, notice we have x solved for. X is all by itself. So we have x equals negative 2y. And again, equals basically means is, like, right? The same thing. Like if I wrote 3 equals 3, that's the only thing that works, right? I can't do 3 equals 2. I can't do 3 equals negative 19. It has to be 3 equals 3. 3 is the same thing as 3. So if I go here, I'm saying x is the same thing as negative 2y. So then in this second equation, I could replace this x with negative 2y, since I said they're the same thing. Right. Now, we have one equation with one variable, so we could solve for y. Negative 2y plus 8y is going to be positive 6y. Then we just divide by 6 to get y equals 2. And now, again, we have a y value. We have a y value, and we still need our x value because remember, our answer is a point. So we can plug it into the top or bottom. The top looks easier for multiple reasons, not just because it has less stuff, but I'm looking for x, and x is already solved for up here. So what I'm going to do is that's x equals negative 2 times y, but we just said y is 2. So I'm going to substitute in or replace y with 2. And then I get x equals negative 4. So then our answer would be the combination x value first, negative 4, and then y value 2. Just like when we graphed, we got a point as a solution. Just because we're not graphing doesn't mean that an ordered pair is not a solution, right? We need that ordered pair because it's saying that these two values together, this x value paired with this y value, is what makes both of these equations true. Any questions on our first example here? Okay. Let's go through a couple more. If you don't finish writing something down, I'll post a link to the video, and so you can just leave yourself a little bit of space. You can leave yourself a little bit of space and just finish it later, write it down later. So now the problem with this one is we don't have anything immediately solved for, right? So what I'm going to have to do is I'm going to have to change one of these equations so that I have something solved for. And if I'm looking at this first equation, it's not looking that nice to solve. But if I look at this second equation, y is almost by itself. We really just need to add this 3x over, and that's not that much work. So that's exactly what I'm going to do. Minus 3x plus 3x cancels, and I'm left with y equals 3x and negative 13. This negative 13 doesn't have an x, so we can't combine them. So we keep them separate, 3x minus 13. And now I have a variable solved for, right? Y is all by itself. So now if I'm saying y is 3x minus 13, then I can plug it back in to this equation up here, right? I want to do it to the other equation, the one that I didn't start with, because if I plug it back into this one, that's just redundant. It's just telling me the same thing, right? Because that's how I got this. So if I plug in this for y, I'm just going to get 3x minus 13 equals 3x minus 13, right? It's not going to tell me anything. So I have to plug it back in to the other one. And then I get 4x plus 5 times y, but we just said y is the whole quantity, 3x minus 13 equals 11. And now at this point, it's again just algebra. So we have 4x. We're going to distribute this 5. 5 times 3x is 15x. 5 times negative 13. 5 times 10 is 50 times 3 is 15. So together that'll be minus 65. 4x plus 15x is 19x. And then suppose we could write minus 65. Then add 65 to both sides, and we get 19x equals 76. And the 76 divided by 19, something nice? I bet it is. Yep. So then divide both sides by 19. I get x equals 4. Oh, but we're not done. We still need our y value, so we got to come all the way back up here. Now, here's a trick with these ones, right? I said you have to plug it back into one of these two, which is true, but we can also plug it back into this one that we found, because this equation is equivalent to the one we had up here anyways, right? So if I could plug it into this one, and this equation is really the same thing, just with stuff moved around, I could plug it back into this one, which is what I'm going to do since I'm looking for y, and y is already solved for here. So y equals 3 times x, which we just said, I'm looking here, y equals 3 times x, which we just said was 4, minus 13. 3 times 4 is 12, minus 13. 12 minus 13 is negative 1. And so, again, that is not our answer in itself, but our answer is the point, the ordered pair, where x comes first, the x value always comes first in an ordered pair, in a point 4, and then y is negative 1. That is our answer. I'll give a little wait time for anyone that is taking notes to write some of that down as well. What's that? Three times 4 is 12, right? 12 minus 13. If I have $12 and I try and buy something worth $13, how much am I going to go in debt? Oh, just from adding this 3x over. So y minus 3x here, if I add 3x, those cancel, but if I add 3x here, then I have positive 3x minus 13. Oh, I see what you're saying. No, because 13 doesn't have an x with it, so they're not like terms, so you keep them separate. Yeah, you can almost think of that as like apples and oranges, right? Like this is 3 apples and this is just 13, right? So the 13 what we don't know, so they're not the same. You can't combine them. I see what you're saying now. Yep. Good questions, though. Good questions. Any others? All right. So let's move on to this one where, or let me check out. So on this one, something is nice and y is already solved for here. So since y is solved for here, I'm going to plug it into this equation. So we have negative 6x plus 3 times y, which we just said y is the entire quantity 2x minus 4. And it's really important that we put this in parentheses, right? If I'm saying y is 2x minus 4, that whole thing, and I say 3 times y, then I should get 3 times the whole thing, 2x minus 4. And again, this just takes a little algebra, which we've been working with all semester. 3 times 2x is plus 6x. 3 times negative 4 is minus 12. And then that's going to equal negative 12. Now, something interesting happens here. What's minus 6x plus 6x? Yeah. Raph, save the baby for your own time. Um, Anyways, yep, it's 0. Or another way maybe to even think of this better is what happens if I maybe add this 6x over? Let me add that 6x over. All right, then those ones will cancel, but I'm still left with this 6x here, minus 12 equals 6x minus 12. Well, these are the same thing, right? So what is this telling us? This is telling us that um, we have an infinite amount of solutions, right? If these two are the exact same, no matter what I plug in for x, it's going to be true. So I can plug in anything for x, and then whatever I happen to get out for y is going to be the same thing in both cases, right? So that this graphically is the same thing as when, remember, graphing was when their points where they crossed was the answer. Graphically, this would mean that they were the same line, right? And so that's what that one is. All right. And so the last one, same thing. We have y already solved for, so I'm going to plug y back into this equation up here. We have 2x minus, and then make sure we distribute this minus 2x minus 3 equals 8. And so now I get 2x minus 2x minus negative is plus 3 equals 8. And then maybe if I add this 2x over, then I get 2x plus 3 equals 2x plus 8, which is never going to be true, right? No matter what value you plug in for x, so that's going to be no solution.